Okay guys, I am taking you through the answer key. I've written it out. I tried making a film while I was writing it, but it just got to be too long. So here we go. We're given these 3 points, M, P, and Q, and plot them carefully. Make sure you do X and then Y. I plotted it down here. I'm going to go back and forth between the two. But here, this is the first one, M, P, and Q. So this is my first triangle. And then it asks you to reflect it over the y-axis. This is our vertical y-axis. When I reflect it over, I've got these points. I plot them very carefully with M prime. I will see it, P prime, and Q prime. Just be as neat as possible. And there it is, reflection over the y-axis. And I've labeled it carefully. Then it asks to do another transformation, and that is to take this second one. Be careful that I'm telling you not the original one, and don't come and ask me because it's actually fairly clear up here where I say reflect transform M prime, P prime, Q prime. So that's the second one to a new one, so it's double prime, and everything gets bigger by a factor of 2. So 2, 7 becomes then 4, 14. And so okay, it's going to be big and it's a little bit awkward going off the page like this. On the test, this one will probably fit on the page. So check your work if you are going off the page. You probably made a mistake. That is called the dilation, centered at 0, 0. Centered at 0, 0. If you forget to write that, you won't lose much. But do know the names of all the different transformations. That's a dilation. It's getting larger. Is this a right triangle? And it is a right triangle because I went and I calculated the slopes. You can choose any one of those 3 triangles. And when you find the slope, this is a slope of -2, and this is a slope of +1/2, and they are opposite reciprocals is what those are. That means they're perpendicular. That means it's a right triangle. Then I write this matrix. I've done the matrix math down here where I multiply them. You can do that on your calculator. You get this new one, and this is for M triple prime. We go up as high as that sometimes. And Q triple prime, and then I plot it, and that is it down there. And this is a rotation, and that stands for counterclockwise 90 degrees. It's going against the hand motion of a clock, and you can see it's like I've taken this and I pivoted it right here and spun it 90 degrees that way, or like that, I guess. Okay, that's the first page then. This is pretty straightforward. On this page, we're just using the distance formula. We get 25. You can plug it into your calculator. It's worth programming it. Here's the midpoint. We just average the x's and average the y's. Do show your work clearly so I can see how it's found, right? And there's the midpoint, there's the distance. Now this one is quite difficult. This problem is harder. You might have noticed that I say do not use any new variables, and that's where you have to use a little bit of Pythagoras and some real geometrical smarts here. This is one that has often been one of the most difficult types of problems on the test. But you'll notice that to get to this point right here, I'm going over B and up some unknown amount with the question mark. The total length, though, I know is A because it's a rhombus, all right? So if that diagonal length is A and this amount you're going over is B, we can write a little equation that says that this then is equal to the square root of A squared minus B squared. I'm just going some backwards Pythagoras to solve that. So the correct answer for 1 is the square root of A squared minus B squared. I'm not using any new variables, and that's how far up you would go in the y direction. 2 is a little bit easier. It's just A plus B. I'm going over to point C, A amount plus that little B amount, and then I'm going up the same as I went in this point right here. So I'm going up that A squared minus B squared. 4 is the easiest one. I'm going over A and up and down nothing, so that's 0. All right. Here I've got a kite, and the kite is oriented this way, we can assume, and that means that if I've gone over some amount A, directly above it, I'll also go over the amount A. Then I'm going twice that amount over because of the symmetry. That's your symmetry line for kite. I'm going to go over 2A and then up the same amount that I went up here, which is B. So that's fill in the blank number 3. Okay. Finally, how would I use GeoGebra to construct a parallelogram with sides in a 3-to-1 ratio? Well, there are two good ways to go. You could either start with a short segment like this and then some random long line that goes like this, and by drawing a circle like right here, I will get these the same length, and then by clicking on this point and here I can do another circle, and then these will be the same length because they're both radii, and clicking on this and clicking on this and doing a third circle, these will be the same length. Then I would just click right here, click right there, and make a parallel to this one. Then I would click up here and click on this line right here and make a parallel this way, and this then will be my parallelogram. That's an easy way to do it. Another way would be to make segments and then find, I would start off with a segment AB, and then I would make a midpoint M1. I'd make midpoints for each of those halves of the AB part, and then with these four equal parts I could make a circle the length of the first quarter, and then make a parallel at the third quarter, and then a parallel at my first point here, and this would also be one in a 3-to-1 ratio. You just need to be able to move it all around and have it always stay 3 times as long this way as that way. Alright? I've abbreviated the steps here, and you can kind of just read through them. I just say make segment AB, and then create midpoints M1 and M2, and a final midpoint M3 right there, and then a random point C to get that segment started. I could have made it also a line, it doesn't have to be a segment. And then I make a circle with a center at A going through M3, and then I find point D. It's a little bit hard to see, but there'd be point D, and then I construct parallel lines at D and M. That would be enough to convince me that you knew how to do that. Alright, on to the next page here. We're asked, given these large coordinates, to decide what this shape is. Okay, now plot them very carefully, and once you've done that, I would go from point A to B, I would go up and over. That will find the slope, and it'll also help you find the distance. Turns out I go up 35 and over 105 units. That means it has a slope of exactly 1/3. The distance then, that length, is 35 squared plus 105 squared square rooted, and you can find that on a calculator. I didn't even bother to do that because when you do this one, you'll see this one's over 35 and down 105, so it's the exact same number. So clearly these are the same length, and they have opposite reciprocal slopes, so that is a right angle in there. So it's kind of looking like a square, but when I do this one, you'll find out that the numbers are slightly different. This is down 39 and over back 107. This slope then is something slightly steeper, I believe, than 1/3. You can try it on a calculator. The best way to do this on a calculator is just to divide 39 by 107. You get a decimal and then go into fraction. Find out the decimal and then go into fraction. And if you get 1/3, it's reduced it for you. You certainly should know how to reduce a fraction, but that's a quick way to do it on a test. And then if I do this point D to A, this is point D, you'll see that this one's back 33 and up 109. So that's different than 39 and 107. But if you do Pythagoras, you'll see that both of these are the same. They both work out to be the square root of 1,000 or 12,270. If you go decimal only, sometimes the decimals can be close. If you go with the exact radical answer, you'll see that it is exactly the square root of the same number. So these are equal, but different than these. So I've made this, I've marked it as such, and that is, of course, a kite. So the best answer would be to call this a right kite because it has a right angle. If you didn't say that and you just said it was a kite, that would be good. I might give you some extra credit if you came up with a little detail like that. Finally, they want you to use analytic geometry to prove that the property of a kite is true. Well, one of the properties of a kite is that these two diagonals are perpendicular. If you find the slope, you'll see that the slope for this line here is 2 and the slope for this line is -1/2. You could also have found the midpoint here, and you could show that the midpoint lies on the equation for this line and that this is the same length as that, but that would be a bit more complicated because you would have to work out the midpoint and then show that it's on whatever equation you found for that line. So definitely the easy way to go is to prove that the diagonals are perpendicular, and I should write a little perpendicular sign in there. Alright, finally, we're into our draw quadrilaterals. Make sure you understand these are quadrilaterals, no triangles, no hexagons, nothing like that, that fit. These are our parallel sides, and we can have no parallel sides. We can have one pair, or we can have both pairs of parallel sides. So this is basically saying this is a parallelogram in this column. All right, special types of parallelograms. No lines of symmetry, one line of symmetry, two lines of symmetry. You can have none with a parallelogram that hinges over. You can have two when it locks into a rectangular position, but nothing in between. With this row here, you've got two lines of symmetry, but here no pairs of parallel and one pair, and that's impossible as well. But these ones are all possible, and if you think about your properties, you will be able to come up with those as well. I would think it's just a matter of sketching lots of little examples until you realize, starting with the conditions, that you've got like one line of symmetry here, and you can't have anything parallel. If you start playing around, you'll see that it is possible. Here you want one line of symmetry and then two parallel sides, but two that aren't parallel, and you'll come up with that. All right? Good luck on the test, folks.